Cool. So thanks for inviting me to talk. So what I will be talking about today is switching between space and time, spatial temporal analysis with cubble. A little bit about myself first. So my name is Zhang. I'm a Ph.D. student at Monash University in Melbourne, Australia. So for us now, it's nearly 10 a.m. on Friday. My research centers on exploring multivariate spatial temporal data with data wrangling and visualization tools. And here are the details where you can find me on Twitter, GitHub, or my website. Often, spatial and temporal data are stored separately, and this is convenient for data collection, but not for the analysis. Joining spatial and temporal data into a long table is not necessarily the best way to represent the data. This is because the inefficient memory use due to the repeated information, especially when these large geometry objects are met with the frequent temporal data. And this motivates me to think about how to arrange spatial temporal data for data analysis. And ideally, we would like a data structure that can easily pivot in between spatial and temporal form. And it will be a plus if the interface is a table or a data frame so that we can use the functionalities from existing packages that we use for spatial and temporal analysis. So today I will be introducing a new data structure called cubble for vector spatial temporal data. A cubble has two forms, which you will see shortly that they can be pivoted back and forth. Here I will introduce the two forms. So in the nested form on the left, the spatial variables are in columns, and you have temporal variables all nested in a list column called TS. And in the long form, the time series data are shown in columns, and each row is cross-identified by the site and the date in the long table, hence it's called long form. With cubble, you can easily pivot in between these two forms for the analysis. So in general, spatial operations will be performed in the nested form on the left, and the temporal operations will be carried out in the long form on the right. And the pair phase spatial and phase temporal is used to switch the cubble between these two forms. With phase temporal, the focus of the data is on the temporal phase of the spatial temporal cube, and this corresponds to the nested form. And with phase spatial, the long cubble is switched back to the with phase spatial, the long cubble is switched back to the nested form and the spatial form for the data cube. Here I have a syntax comparison with and without cubble. On the right-hand side with the cubble, you can do some spatial analysis in the nested form, which is the form where CB objects is built upon. And then you can pivot into the long form for some temporal analysis, and then pivot it back to the nested form for some more spatial analysis. And sometimes these spatial or temporal analysis would include extracting some interesting sight from the data that you have. I have highlighted some code on the left that you will have to do if you are doing two separate tables. So basically what they do is they select one table and take out some interesting ID and filter it on the other table. So in cubble, these updates are automatically handled by phase spatial and phase temporal. So you don't actually have to do these manual updates on your spatial or temporal data to match them up. And also the cubble pipeline chains up all these operations together, and there's no intermediate objects that's being created in the workflow. So now let's see cubble in a data set of Australian weather station. So on the left, I have the stations data, which records 30 weather stations along with their longitude, latitude, elevation, and name. On the temporal side, we have precipitation, maximum and minimum temperature. These are collected daily for each of the stations in 2020. So to cast the two separate tables into a cubble, you can supply them in a nested list as what has been highlighted here. You also need to tell cubble some identifiers it looks for. The key argument is the spatial identifier that connect the two tables. The index arguments is the temporal identifier that prescribe the timestamp, and there's the codes argument that used to specify the coordinates. So from the cubble header, you can read that the key here is ID. There are 30 stations and the data is in nested form. And the third line in the header here also shows you the available temporal variables along with its type, so that you can refer it back, and later I'll introduce how to do that. Also, if your spatial and temporal data is an SF or a civil object, they will be indicated in the cubble header as well. So here is what a cubble look like when being switched between the long form and the nested form. So with the weather objects that we just created, we can turn it into the long form with the function phase-temporal. Notice here the third line in the header now changed to show the spatial variables that make it easier to referring back and forth. On the right, weather long is switched back to the nested form with the function phase-spatial. As you can see from the last line of code, phase-temporal and phase-spatial are the exact inverse. So we have the weather back and weather to be exactly the same. So sometimes you might need to access variables from the other form for your analysis. For example, we may want to calculate some per station summary of the time series data. And we can refer to the temporal variables from the nested form with the $sign. And here I'm calculating the average maximum temperature across the whole year for each of the station. And I need to get access to the Tmax from the list column TS. So it's just TS $Tmax. And in the long form, you need a cubble verb unfold to move the spatial variables into the long form. So here I move the two coordinates columns into the long form, and later we will see how it can be used to create a glyph map to explore the space. Sometimes, although technically we have spatial temporal data, we may choose to fix a few stations to explore their temporal patterns, or select a few timestamps to explore their spatial distributions. So in that sense, we're treating them as spatial data or temporal data rather than spatial temporal data as a whole. And a more holistic approach is to explore the space and time simultaneously. And now we will see an example of how to use cubble to explore temporal patterns across space in a glyph map. The glyph map is essentially a transformation of temporal variables into space. And I have a short illustration here to show you how the transformation works. So in one, there's a single station on the map with its longitudinal and latitude coordinates. And two is its associated time series data. And in step 3 in here, the temporal axis is transformed into the spatial scale with linear algebra. And once we have the time series in the transform scale, they can be placed on the map as in full. So to make a glyph map, you can use the geom_glyph function from the cubble package. And it requires a pair of major and a pair of minor axes as the required aesthetic. The major variables are the spatial coordinates, so it will be long and lat here. And the minor variables are the temporal coordinates, which will be the date and Tmax here. So this is a full example of using glyph map to explore Australian weather pattern. The code here has 3 blocks. In the first block, we create a couple objects from the stations and TS data as we have seen before. The second block here involves wrangling the data using the nested and the long form. Sampling 20 stations is a spatial operation, so it is performed in the nested form. Then we need to do a summary of average maximum temperature by month. And this is a temporal operation, so the cubble needs to be switched to the long form with phase-temporal. The glyph map requires both the spatial and temporal axes to aesthetics. So we move the column long and lat with unfold into the long form. And the last chunk here it shows the ggplot code to make the glyph map with geom_glyph. On the map, you can actually see the temperature curve in the north and south, temperature curve. And in the north and in the south, especially the Tasmania Island, the temperature curve is relatively constant throughout the year. And also those inland stations, for example, those in the Eastern Australia, has a much visible variations throughout the year as comparing to the coastline ones. For example, you can see the inland ones has a U shape, while like the coastline stations would be much more flatter. And remember, Australia is in the southern hemisphere, so winter is in June, July, and August. So we have a temperature curve of a U shape rather than the fun face curve. And so that wraps up my talk today. Cubble has already made up its way to Chrome, and there will be a version update that really soon in maybe like next 2 weeks. So stay tuned and thanks for listening.